All right, this is lecture 5.1, operations with functions. The essential standards. I can understand the mathematical terminology used to combine functions together, and I can combine functions with addition, subtraction, multiplication, division, and composition. I can find the domain of those combined functions. Okay, we're going to do composition at a later date. Okay, so functions can be combined with addition, subtraction, multiplication, and division. That's what we're going to focus on today. And the mathematical notation for this is as follows. So we need to understand what these symbols mean. So here's what addition is. So essentially, I have f plus g of x. And so you can rewrite that as f of x plus g of x. And we know that this is addition because of that symbol right there. Multiplication, for example, will be f times g of x, and you can make that f of x times g of x. And again, this is the symbol for multiplication. Subtraction, f minus g of x is the same as f of x minus g of x. And once again, here is our order of here's our operation, which is minus. And then we have last one, f divided by g of x. So f of x divided by g of x. And once we cannot have g of x equivalent to 0. So we will have to find our domain in that situation. We will have to find the x's and exclude them if g of x is equal to 0. So when functions are combined with these operations, the domain, which is what I was just talking about, of the combined function consists of the input x values, the inputs, the x values, that work for both the original functions minus any additional values excluded because of the division by 0. So let's do some examples. Okay. So given that f of x is that polynomial and g of x is x minus 4, find each function and its domain. So we can rewrite this as f of x minus g of x. Now let's go and evaluate f of x. So f of x is then defined as x squared minus 3x minus 4. And then we are going to subtract from it g of x. Now we are going to subtract the entire function g of x. So make sure you pay attention to your um, uh, parentheses in that case. So now I'm going to distribute that negative, combine like terms, and well, let's just minus 3x minus 4. I get minus x plus 4, and then I will combine like terms, and I will get x squared minus 4x. And there is my answer. Now they wanted to know its domain. This is a polynomial, x squared minus 4x. And in this situation, I have no radicals, no even radicals. I have nothing that's divisible by 2. And there are no restrictions on my x values. So the domain is all reals. All right, how about trying one yourself? Welcome back. And so this simplifies to f of x plus g of x. I'm going to go get f of x, which is x squared minus 3x minus 4. I am going to add g of x, and that will be x minus 4. We don't have to worry about parentheses. There's no subtraction. I will combine like terms, and I will get x squared minus 2x minus 8. And the domain is all reals. There are no restrictions on my x values. Okay, let's do another one. All right, so we have g of f of x. So this will be, I'm sorry, g times f of x. It can be written as g of x times f of x. Well, what's g of x? It's x minus 4. What is f of x? It is x squared minus 3x minus 4. Okay, so here's my f of x. Here is my g of x. All right, now we use our FOIL, and we're just going to just multiply through all the x values, all the negative 4. We have to multiply each term within each polynomial. So I will get x cubed minus 3x squared minus 4x Then I will multiply through by the -4, and I will get -4x squared plus 12x plus 16, and then I will combine my like terms, and I will get x cubed minus 7x squared plus 8x plus 16, and this is my answer, and this is all reals is my domain, because there are no restrictions of what my x values can be. Okay, let's try one yourself. D, your turn. This is the same, welcome back. This is the same of f of x times f of x. And so what is f of x? F of x is x squared minus 3x minus 4, x squared minus 3x minus 4. And they're both what we've been using as yellow. Then I have to FOIL, I have to multiply each term in the second polynomial by each of the terms in the first polynomial. Now, in the past, if you recall, there was a lesson where we had considered that A, and this would have been B. And notice the sign here, those are both negative. The reason why it worked in the past was one was negative and one was positive, and we had the center term cancel out. But in this case, that does not work because they're both negative. So we actually have to go through the entire multiplication of each of the terms in the trinomials. And so it's a little bit of a challenge, but it's not something that I'm sure that you can handle. So I'm going to multiply each term by x squared first, and I will get x to the fourth minus 3x cubed minus 4x squared. Then I will multiply by negative 3x through each term, and I will get negative 3x cubed plus 9x squared plus 12x. And then I will multiply through by -4 to each one, and I will get negative 4x squared plus 12x plus 16. I will then add all my like terms. I will get x to the fourth, 6x cubed, oops, plus x squared plus 24x plus 16. And my domain, again, is all reals. There are no values of x such that the function is undefined. This is my domain. Okay, moving on. Given that f of x is the binomial x plus 2, g of x is x squared minus 4, find the function and its domain. So now I have some division. I have some feeling we're going to have some domain restrictions. So this is the same as f of x divided by g of x. So what is f of x? F of x is x plus 2. And so we'll write x plus 2 in the numerator. G of x is x squared minus 4. We have to do some division. X squared minus 4 simplifies to x minus 2 and x plus 2. Now, here is the point that I need to make. This is very important. I have to find my domain. So we have to find the values. We have to find the values of x such that the numerator does not equal 0. I can't divide by a 0. Okay, I can take this item in pink, this x squared minus 4, and find the values of x. It's the square root of 2 or square root of 4, which is equal to plus or minus the square root of 2. I could also just look at these after I've factored it, which is what you need to do in order to divide. And you should be able to quickly see that x, in order, if you set those equal to 0, you find that x is equal to 2 and negative 2. But here's the key. This will simplify, and it will simplify to 1 over x minus 2. So this is the answer. And so you might say to yourself that the domain is the x value cannot equal, if I focus on this part, 2. You would be wrong, okay? So you must find domain the domain before you simplify. Okay, so the values of x that such that this function is undefined is not only 2, but it's also -2. So it's plus or minus -2. Okay, so you have to find the domain before you simplify. All right, so why don't you try one yourself and find the domain before simplifying your answer. Welcome back. We have g of x divided by f of x. We know that g of x is given here. So we have that on top. And we have our f of x, and we'll have that on the bottom. So g of x is 2x plus 14, x squared plus 5x minus 14. And now I've got to divide it. So how do you divide these polynomials? First thing you do is factor them and simplify it so you can actually cross out things that, and so the top has a greatest common factor of 2. So I pull out my 2 and I get 2 times the quantity x plus 7. And on the bottom, I can actually factor that. Now I can do this and find my domain, and it actually helps me find my domain. Or I could set this whole thing equal to 0, which you would eventually have to factor. So you're kind of doing both at the same time. Got to find two numbers that multiply to 14 that add to positive 5, and that will give me a 7 and a -2. And now I must figure out my domain. So I know that my domain, I cannot have 0 in the denominator. So x cannot equal -7 and +2. Okay, so I've kind of lost where I'm at, but at any rate, we found that the domain cannot, x values cannot be -7 and 2, because that would cause that numerator to become 0, and we can't divide by 0. Now we can simplify, and our answer will be 2 over x minus 2. What did I do wrong? I'm on the wrong problem. Hold on. No, I'm not. This is the answer. 2 over x minus 2. And the domain is all values of x's except for -7 and 2. All right. Moving on. Now we have some additional examples where we need to use the table to find each value. So we have f minus h of -3. This is the same as f of -3 minus h of -3. And this time we're going to use the table. Okay, so we have f of -3. So we go over here, and once again, the x value, or our input, is -3. So we find -3, and we find what is f of x when x is -3. And that will be a 9. So our output is a 9 minus h of -3. So we have h of -3, and we find that value to be 5, and that will be 5. So the input is -3. The output for f of x is 9. The output of h of x is 5. 9 minus 5 is 4. Okay. Then we have b, which is h of -1 times g of -1. And we will then go and find the value of h when x is -1, and that will be 2. And the value of g when x is -1, so our input is -1, and that is 3. So we have 2 times 3, which is 6. So why don't you try 2 yourself? Welcome back. I have g of 3 plus f of 3. Okay, so you've got to go to the table and find the value of g when your input is 3. And that value will be 11. The value of f when the input is 3, and that value is 9. And your answer will be 20. And then we have one more. This is h of 2 divided by f of 2. And we'll go and find the value of h when x, our input, is 2, and that is negative 10. And then we have the value of f when x is 2, and that value is 4, and that will be negative 5 halves. Okay, so we use tables, we've used expressions. We can also use graphs to do these types of mathematical computations. So let's take a look at this. So we have f plus g of negative 2. So that can be rewritten as f of negative 2 plus g of negative 2. So f of negative 2, what does that mean? So negative 2 is our input. That is our x value. So we will go to the graph and look at where x is negative 2. And we got to look at the right graph. So this is f of x. So here is negative 2. And we want to find the output. When x is negative 2, we find that the output, the y value, is negative 4. I take a look at the graph and I go look at what the output is. And so that is negative 4 plus g of negative 2. So I've got to go to the correct graph of g of x. I go to negative 2 and I look at the output. Output, g of x is the output. That's a fancy way of saying y. And that output is located right there, and that will be a positive 3. So negative 4 plus a positive 3 gives me a negative 1, and that is my answer. And then for B, I have f of negative 3 times g of negative 3. And I do the same thing. I essentially go and find on my graph where x is negative 3, what is f of x? And that is going to be a negative 3. So I have negative 3. And then on g, I go to g of x, and I also go to x of negative 3, and I will find what is my output. I go to the line, I look to the y-axis, and I find that to be 4. And if I multiply those together, my answer is negative 12. Okay, how about trying 2 yourself? Welcome back. This is f of negative 4 minus g of negative 4. So let's use a green this time. And we will go to the graph and find where f of x, where our input, our x value is negative 4. What is our output? Our output is 0. Okay, it's located right there. So our y value is 0. Minus, if I take and look at negative 4 on the x-axis for g, because negative 4 is my input, I've got to go up to the graph, and I find that it intersects the graph right there. And what is the y value? That is a positive 5. And so my answer is negative 5. All right, so this is rewritten as g of negative 1 divided by f of negative 1. Okay, so what do? We go look at our x value of negative 1 on g, and I find that my output is a positive 3. I divide by f of negative 1, go to negative 1, and I find my output is a negative 3, and I find my answer to be negative 1. Okay, 3 more to go. Find the requested values if f of x is defined as given and g of x is also defined as given and h of x is defined as given. All right, so this problem A, I just want to focus on that carefully because it could be confusing. So let's focus on A for just a minute. We have 2 times f plus g of 1. So this can be written as 2 times f of 1. Let me rewrite that. 2 times f of 1 plus g of 1. Okay, so the x value is defined as 1, and we're going to just multiply the f of x just times 2, okay? So that's the first time we've had a situation where we have a um, constant value multiplied times the expression, but it's okay because we know we can multiply the entire f of x times a constant, for example. So what do? Well, we take that 2, we're going to bring it down. Oops, there's my 2. And I need to multiply it times f of 1. So let's find the value of f of 1. So f is defined as this. So I'm going to plug in 1 for x. So I get -1 plus 3, and that will give me a positive 2. Plus, and then I take 1 and I plug it into g of x. So if I plug 1 in for x, I get 5 times 1 is 5, plus 1 is 6. So 2 times 2 is 4, plus 6 is a positive 10. All right, how about this one? We get h of 4 divided by 3 times f of 4. Okay, so I've got to go find what is h of 4. So for everywhere I see an x, I plug in 4. So I take 1 minus 4 squared. 4 squared is 16. And so that gives me 1 minus, that is -15 on top. Actually, I'll go this way. -15. And on the bottom, I have, I'm sorry, f of 3 times f of 4. So I'm going to take 3. I got to take 4 and plug it in for x anywhere I see an x and f of x. So I get -4 plus 3. So that's -1. So that gives me -15 over -3, which is equal to a positive 5. All right, try one yourself. Welcome back. I get h of -2 minus 2 times g of -2. So we're going to determine what h of -2 is. Plug in 2 for x, I get 1 minus 4 squared, which is 1 minus 16. So I get -1 minus -2 squared. So it's 1 minus 4, which gives me a -3. And then I will subtract 2 times g of -2. So plug in -2 everywhere you see an x up at right here, and I get 5 times -2, that's -10 plus 1. That gives me a -9. And so 3 minus 18. I'm sorry, plus 18, because the negatives cancel, and I get 15. All right, that concludes my lesson for today. Reach out to me if you have any questions.